Substitution into algebraic expression. This is a very interesting topic in mathematics. Let us look at a scenario where you were asked to go and represent your little brother at his graduation, but somehow you got sick and somebody else is asked to go instead of you. So that person would actually be replacing your attendance. And so we won't have you anymore to go because you're sick. So somebody else will go. So this person will be replacing you, or being this person will be a substitute of you. So we were looking at that concept we were using that concept or that analogy as it relates to substituting into algebraic expression. As you can see, these are some expressions that we have. These algebraic expression with coefficients and variables and so on. So all we'll be doing is plug into these expressions by looking at what the variables are actually equal to, and then we evaluate these expressions. So if a is equal to 5 and b is equal to 2, what would a plus b be? So we'll just substitute. If a is 5 plus b is 2, then this gives us 7. If we do the same thing for number 2, we have 5 minus 2, and that will give us 3. If we should do the same thing, just substitute a and b into 2 times a plus 3 times b, then we will get 2, put this in parentheses or brackets, 5 plus 3 open bracket 2 close bracket. So we'll have 2 times 5, which is 10, plus 3 times 2, which is 6, and this gives us 16. Let's look at number 4. So we have 5 times 5 plus 2. And so we'll work on what is in the bracket first, and then we add the product with 2. So we say 5 times 5 gives us 25 plus 2, which is 27. And so there you go. The substituting the variables with numbers and evaluate. So let us look at another example when we have x is equal to 4, y is equal to 7, and z is equal to 2. So we'll just do the same thing. We'll just substitute for x is 4 plus y is 7 plus z is 2. So let's just add these. If we have 4 plus 7 give us 11. 11 plus 2 gives us 13. So let us look at another one. So let's say we have we have 2x minus y plus 3z. So we just substitute for the variables x, y, z. So we have 2 times 4 minus 7 plus 3 times 2. And so we just go ahead and evaluate this expression. 2 times 4 gives us 8 minus 7 plus 6. And so when you have this these kind of expression with addition and subtraction, we normally start from the left hand side and we go to right. So we'll say we work these first, which will give us 1, and then we add that to the 6, it gives us 7. Let's look at another one with these same substitutions. So say we have x squared plus 7y plus 5x. So when we substitute x for when we substitute 4 into x squared, we get 4 raised to the second power plus 7 times 7 plus 5 times 2. So when we have exponents, we normally work out what we have in the exponent form. So that's a 4 raised to the second power. So we say 4 raised to the second power that will give us 16, and then we can just multiply what is in the bracket. So we have 49. 7 times 7 was 49 plus 10. So let's just add these numbers. So 16 plus 49 is 65 plus 10, and that gives us 75. So let's use some negatives in our expressions, because negatives, students or most people are actually afraid of negatives and are afraid to actually substitute negative numbers into the expressions and evaluate. So let us use some negative numbers. Let's say we change the variables and we change the variables to be m is equal to negative 2, n is equal to 4, and p is equal to, let's say, 3. So if I have an expression, let's say I have an expression as p plus, let's say p plus, let's say minus 2n. Now what will this this expression be after substituting the numbers into the expression? So we have p is 3 minus 2 bracket minus bracket 2 minus, so 3 minus 2 times 4. So how would we actually work this out? Well, according to the order of operation, we normally work out what is in the bracket first. So we will say 2 times 4, that gives us 8, and then we say 8 3 minus 8, that gives us 5, negative 5. So what we need to understand, whenever we could use this example or this idea to actually subtract big numbers from smaller numbers. What we could do is that we could say, whenever we see negative, remember whenever you see a number and you're seeing a negative at the left side of the number, that number and the negative sign, they are married. They actually one. So you don't say 8, but you say negative 8. Or you want to say Mrs. negative 8 or Mr. negative 8. So whenever you see a negative, this simply means that you owe. So if you owe $2, if you owe $8 at the shop and you only have $3 in your pocket, then when you pay the shopkeeper the $3, you will still be owing the person $5 more. So we put a negative side at the left side of the 5, and we call it negative 5. So those are some of the things that persons tend to fail to understand or try to approach in such a confident way in solving negatives. Let's look at another question. Say I have say I have m say I have m square minus 4 m plus, let's say, negative 3m. So how would we actually solve such a question like this? Well, I want you to go ahead, pause the video, and go ahead and try to solve this. So let's look at it. If we have, let's see, I will substitute the values. We just have, we have just m in this expression. All right, so we could actually evaluate these. We could group the like terms and evaluate them if you want, or we could just simply just substitute the values into the value of m into the expression. So it doesn't matter which way we want to do it. But if you want to look at it in a simplified way, no problem. We could actually simplify this by saying m square, and if you owe 4m at the shop and you go a second time and you owe some more, which would be you owe 3 more. Uh, you're actually increasing your debt, so you're actually owing more money. And when you see a negative and a positive, when they are clashing, we know that the negative is always stronger. So what these two operations will turn out to be a negative. So we have a negative 4m minus 3m, and that will give us negative 7m. So that's what this expression is saying. So all we're going to do now is to substitute the value of m into the expression, and then we evaluate it. So if m is negative 2, so we have negative 2 raised to the second power minus 7 times negative 2. And so we actually have some set of negatives in our expression. So we'll just go and work out what is in the exponent form, which is negative 2 raised to the second power. So this is actually saying negative 2 times negative 2. That's what exponent does. It actually multiply the base by itself the certain amount of time, depending on what the value of the exponent is. So this is saying I must multiply 2 identical negative 2. And then I could just put these in brackets, seeing that we have so many negatives, so we don't want to confuse ourselves. And then we could just go and multiply. We could actually just write. Could actually go and multiply these. So we could say 7. We could say negative 7 times negative 2. So a negative times a negative gives us a positive. And so we could just continue solving this. We could say negative 2 times negative 2. That will give us positive 4. Because 2, when you're multiplying 2 negatives, it gives you a positive. And so our answer will be 18. Let's look at another one. Or better yet, let us look at some fractions in substitution. Because fractions are one of the challenges that most students have in substituting. It's just that the same way whenever you are actually simplifying fractions, algebraic expression, or not algebraic expression, but fraction on a whole. So let's look at this question. So if, let's say, we have two variables, x is equal to 10 and let's say y is equal to 2. If I have well, let me work this question first and then we go to a fraction. No, if I have x plus y raised to, let's say, y, how would we actually substitute? How would we actually work this out? Now it's the same way. We just substitute the values, substitute the numbers where there we would substitute the respective values for, well, with the number. So where we see x we put 10, where we see y we put 2. So this will actually be 10 plus 2 raised to 2. And so in this case we'll work out what is in the bracket first, and then we do the exponent. So work what is in the parentheses. So we say 10 plus 2, that gives us 12, and 12 raised to the second power, that will give us 44. Very simple as that. Very, very, very simple as that. Nothing hard. Very simple. So let us look at a fraction. So say we have x divided by 2 plus 4 times y. And it is very, very simple. This is nothing hard for us to try to wonder. But what I'm going to do, I'm seeing a fraction with variables and so on. It's very simple. Just all we're going to do is to substitute the values for the variables. So anywhere we see the letters, we put their respective number. So we will say 10, x is 10 divided by 2 plus 4 times 2. And so we could go ahead and evaluate this. We can do this many ways. We can actually, if we want to divide it, we could divide it. If we want to multiply the 2 with the 4, we could do that. We'll get the same answer. So we could even rewrite this if we want. We could even say 10 divided by 2. We could actually say this is 5. But we can do it many ways. So we could say 2 times 4 gives us 8. We could create a fraction if we want. We could just divide these and actually add the results. So let us look at it and see how it works. Or we could just work it regular fraction. We could try to say find the LCM of this fraction. And we could say, all right, the LCM is what? 2. So if the LCM is 2, say 2 into 2 goes 1 time. 2 times 10. Sorry, 2 into 1 time. 1 times 10 gives us 10. And then we say 2 into 1 into 2 goes 2 times. And that answer we multiply by the numerator of that fraction, would give us 16. So if I say this will give me 26. And so we say we bring back the denominator, and that will give us 2 into 26 goes 13 times. So our answer will be 13. But let us try the other way to see if we get the same 13 for our answer. If we had just word the fraction as though they are, we could say 2 into 10 goes 5 times, and 8 divided by 1 gives us 8, and we say 5 plus 8 gives us 13. So we could do this more than one ways. So let us look at another one. So say we have x divided by y raised to x plus, let's say, 20 divided by 4. So go ahead and take a try and see what you got. So let's go and work this question. So all we will be doing is just substituting the values where substituting the values of these variables and just evaluate the expression. So let's go. X is not x. I meant to write a y. So let's look at this one. So all we'll be doing is just substituting the values. So we say where we see x, we put 10. So we have 10 divided by 2 all raised to 2 plus 20 divided by 4. So based on based on indices, whenever we have a fraction being raised to a power, we know that we will square. We actually um, distribute the exponent to each term in the fraction. So what we actually have, we have 10 raised to the second power divided by 2 raised to the second power. So yeah, let me write this a little better. So 2 raised to the second power plus the 20 divided by 4. And so we can go ahead now and just work the what. So 10 raised to the second power gives us 100 divided by 2 raised to the second power gives us a 4 plus 20 over 4. So we could do this two ways. We could actually divide them as though they are, or we could actually, since they share the same denominator, we could actually just bring back one of the denominator and just add the numerators. So we could say the denominator is 4, so we take back 1, and then we say 120. 100 plus 20, 120, and that will give us 30. So there you go. Just substituting numbers into the expression, and then we evaluate it.